Hi, welcome to another video podcast doing telescope magnification, and I'm going to include a little bit of background information on radians because I think that's something that a lot of students try and duck out on. So first of all, I think we just need to establish what our simple telescope is trying to achieve in terms of angular magnification. So we can imagine a situation where our astronomer is looking at a couple of stars and the angle between those stars is very small, and we'll work in degrees to start with. So we can imagine it appears that the angle between those two stars is 2 degrees. We look at it through a telescope with a magnification of 10 times, and we'll look at how you'd know that in a moment. And what that means is that the two rays that emerge from the telescope, the angle between them has now increased to 20 degrees. It's 10 times bigger than it was, and that means that it's much easier for the astronomer to see the gap. Now obviously 2 degrees we'd still be able to see the gap, but it means that two stars which were so close that they look like one star, the astronomer could now resolve them into a binary star and see the two stars. So how do we know what the magnification of our telescope will be? It's a very simple equation. The magnification of a telescope is simply FO over FE. So FO is the focal length of the objective lens and FE is the focal length of the eyepiece lens. I've got a little cheap telescope, has a 400mm objective lens, and the lower power eyepiece is 25mm. 25 is going to 400 16 times. So it gives an angular magnification of 16 times. Now if we try and put that into practice in a question, this idea of magnification, not an uncommon question to make it just a little bit more challenging is for us to be supplied with some information. That's what we're told. I'll try and keep the numbers nice and simple. That maybe two stars have a separation of 1 light year, but the two stars, maybe they're orbiting around each other, are 10 to the 6 light years from Earth, and we're asked to find the angle between them. And then maybe we were told that we're going to look through a telescope with a magnification of 120 times. What would the angular separation appear to be when viewed through the telescope? Well, a lot of students would be tempted to try and create either quite hard a right angle triangle, hypotenuse is 10 to the 6, opposite side is 1 light year, or maybe even go for a non-right angle triangle. In theory it is actually a non-right angle triangle, but in reality, if you just remember the definition of a radian, it's just arc length, that distance, over radius, that distance, and then we can see that it's a very easy calculation. It's simply 1 divided by 10 to the 6 equals, that angle is really pretty exactly 10 to the minus 6 radians. I apologise for the lack of significant figures in this, but we're just doing this for illustrative purposes. So what angle would the astronomer see? Well, they would just do 10 to the minus 6 times 120, which is 1.2 times 10 to the minus 4 radians. I hope you found that helpful. Thank you very much.